Let's do an example of conservation of momentum. This is chapter 9, number 58. And the problem says 3 identical train cars coupled together are rolling east at 2 meters per second. They're stuck together. I can try to draw this. They're traveling at 2 meters per second this way. These are train cars, if you can't tell from my beautiful artwork. And so this is the before. Then next, car 4 hits and sticks where the speed I'll call V4, which is coincidentally 4 meters per second. So that then we have four cars stuck together, and they're traveling in this direction. Which I'll call, I shouldn't have called that one V4. I'll just call this one V prime, which is unknown. And then next, after that, they hit a stationary car. One, two, three, four, 5 cars. So this one was initially at rest. These guys smacked into it, and now they're all together and they're traveling in some direction V final, which we don't know. So the question is, what is this V final here? That's what we're looking for. And the cars are identical. So all cars have the same mass, and there's no mention of friction. Train cars roll really easily. That's why it's a very efficient way of transporting goods. The friction is very small, so we don't need to worry about friction. So how do we calculate that final velocity? Well, in every collision, momentum is conserved. And the only thing that can change the momentum of a system is if an outside force acts on it. The only outside force that would be acting on these cars would be friction, and we've said there isn't any friction. So we know that since there's no outside forces, the change in momentum of this system is 0. That means P final minus P initial equals 0, which means P final equals P initial. And it's one-dimensional, so we only need to worry about plus and minus. We don't need to worry about those arrow signs anymore. So P final equals P initial scalar. And what is P initial? P initial is the initial momentum of each of those cars. So there's car 1 times 2 plus car 2 times 2 plus car 3 times 2. That's the before thing up here. Okay. And we also have the initial momentum of car 4, which was another car, and it was traveling at 4 meters per second, not 2 meters per second. And then car 5 had an initial speed of 0. So that's just 0 plus m times 0. So that equals 3, well, let's do it this way. Yeah, go away. 2m plus 2m plus 2m is 6m. 6m plus 4m is 10 times m. And the final momentum has to equal that initial momentum. And the final momentum is 5 cars all stuck together times whatever their final velocity is equal to 10m So VF is simply 10m over 5m, or 2 meters per second. Okay, so pretty straightforward.